Okay, so hello guys, back again with another live stream. So today we'll be again doing the same thing. We'll be solving some more questions, maybe from competitive programming or from DSA. So yeah, I was mm, a little inactive from past 2-3 weeks because I got some once I got some fever, and then I went outside for something, and then I came back. So after everything is done, now I am back with stream. Give me a second. So hopefully, just yep. So hopefully I'll be mostly active now. So I'll try to stream as much as possible. This So mostly the stream will be on Saturday because yesterday I didn't get much time to stream. Yesterday I had some stuffs to do. I had to clean my house. Everything was here and there. So for that reason I was not able to stream yesterday. But today I am here back again with another live stream, and today I'll be solving. I'll try to pick the today's lead code contest questions. Let's try to solve the contest question today and see what I was not able to give the contest on time. So I thought of giving it on live stream. So yeah, and from next time onwards, I think a Saturday we have a bi-weekly also. This time it was weekly, and next time it's bi-weekly and weekly both. So I'll try to give both bi-weekly and weekly contest. Yeah. So let me open my Pomo Focus. So as usual, I'll be doing what I'll be I will be streaming for 50 minutes, and then I'll be back. Okay, so I'll be streaming for 50 minutes, and then I'll take a 10-minute of break in between, and in between, like during second half, I'll be taking of 30 minutes or 40 minutes of break for lunch, and after lunch I'll be back again. Okay, so yeah, uh, let's try to give today's weekly contest. Um, this is something red I haven't seen. Once we detect any contest violation behavior, penalties will be applied without prior warning, and will not be waived for any reason. Okay, fine. I'm giving the contest after the contest. So let's see. So let's go for a virtual contest, and we'll try to solve as much as question as possible, so that we can get some insights of how we should solve the questions on during contest. Okay, there are two questions which are 1 and 2. So most probably this question will contain a higher what I would say constraint, and this question will be on easier level, easier side. So if I'm able to solve this, I'll be able to solve this. So let's see. So instead of going question 1 in question 2, I'll directly jump to question 3 and try to solve that. Oh my god, the user accepted is 1237 only. On the fourth question, 1129. My goodness, the question is difficult. Okay, let's see. Let's see. Let's try to figure out. Alice and Bob are playing a game. Initially, Alice has a string word A. ठीक है. Okay. We have a string word A. You are given a positive integer K. We are given a positive integer K. The K is nothing but 5. Fine. Now Bob will ask Alice to perform the following operation forever. Okay. Generate an A string by changing each character in word to its next character in the English alphabet and append it to the original word. For example, performing the operation C generates CD, and performing operation on ZV generate. For Z it changed to A, and for B it changed to C. Return the value of kth character in word. Okay. So I need to handle after Z. I need to go back to A. That is what I have to handle it. So in modeling it with okay. So let's take string str or result starting from A. Is it going to take a what? I need to return the character. Just a second. Generating string is B, word is A, B. Just a minute, I'm getting a call. Just give me a minute. I'm back. I'm sorry. I got a call from of my father. Okay, so let's continue. So where were we? So return the value of kth character in word. I need to return the value of the kth character in the word. After enough operations have been done for word to have at least k characters, note that the z can be changed to a in the operation. So if k is 5, I need to apply operations a, then b, then a will become b and b will become c. Then a will become b, b will become c, b will become c, c will become d. So we have 5. We have more than 5 characters. So fifth character will be 1, 2, 3, 4, 5, which is nothing but b. So I need to return b. This way I need to follow. So it will not be that difficult, I would say. I'll start a count while my count is lesser than k. I will move forward. Count is equals to count plus result dot size, or before that let's do it. Int I is equals to 0. I is result plus result of I plus 1 modulo now let's take it in integer. Integer char will be nothing but result of I plus 1. It will convert it, or it will convert this automatically to modulo 26. Okay, 0 is nothing but a, and 25 is nothing but z. So result plus is equals to character okay, so this character plus a will be added in our string, and after that I'll increase my size of count, and at last I'll be returning a result of k. So count is equals to count plus result of size. No, 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 no. Oh, oh. Oh. Let's see. Let's see. We had a. It changed it to. Oh. A minus A. A B. Then for A it's B, for B it's C. For A it's B, for B it's C, for B it's C, and for C it's D. Right? And now I need the fifth character. 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4. So it should be K minus 1. Right. B and C. Fine. So okay, so this is not that hard, not that difficult for us to solve. Now let's see. Let's jump to the next question. So the next question is count of substring containing every vowel and K consonant one. Count of substring containing every vowel and K consonants. So you are given a string word and a non-negative integer K. You are given a string word and a non-negative integer K. Fine. So we are given this string word and a non-negative integer K. So return the total number of substring of word that contains every vowel. Return the total number of substring. Okay, I need to return the total number of substring of word that contain every vowel A, E, I, O, U at least once and exactly K consonants. Means I need these all vowels and K consonants. For example, if I look at this I, E, A, O, U, Q, Q, I, E, A, O, U, Q, Q. No, K is one, means I need one consonant and rest vowel. So the word length given is 250 only. A E I O U plus K means 1 2 3 4 5. So I E A O U Q. Okay, this contains A E I O U and exactly one vowel, that one consonant, that is Q. Key can go till word dot length. So now this is the first part. Now why the second is, it's 10 to the power 5. Can we go for a sliding window approach? Because it's not a, it's a substring that we need to follow. So we can go for sliding window approach, isn't it? Just a second. Uh, so this is nothing but A E I O Q. So we have to keep track of something like I have A E I O U. So these are our vowels. So we need at least one from all of them. So vowels is 5. We need all of them. We need all of them. Right. Consonants. We need K. That is nothing but K, which is nothing but 1. So can't we go sliding window approach and check? Is it going to create a problem? Let's try. Let's try. I'm not sure why sliding window will not work if I'm here. So long result is nothing but 0, and at last I'll be returning my result. So int I, left is 0, right is 0. We'll start from there, while right is lesser than word dot. So the pre-setups will be something I need unordered map of character comma integer, and of e a e I o and u, and we have vowel as 5, and instead of consonants let's keep k, or consonants as k. So we have something like this. Okay, cook has arrived. Just I'll be back in exact 1 or 2 minutes, or even leave. I'll not go. R is equal lesser than word dot size. Now कुछ भी बनवा लो. और भिंडी है अपने पे तो कम ही है, ज़्यादा है नहीं. सबका तो नहीं होगा. बीन्स का बनवा ले सब. भिंडी और बीन्स के दोनों के बनवाई. भिंडी और बीन्स दोनों के बनवा ले सब्जी. और क्या करेगा, परवल रखा हुआ है थोड़े का, वो भी थोड़े. हाँ हाँ, और वो भी 3 देने का नहीं होगा. तूने कहा ठीक है, तो परवल का बनवा ले. तो लगा मैं तो 4 बनाई मेरे लिए. Okay, so this is a character that I picked. Now if this character is a vowel, if ch is equals to a, or ch is equals to e, or ch is equals to I, or ch is equals to I o just a second. One minute. Came back. I'm sorry. Okay. So where were we? If it is a vowel, now I'll, I'll do what? I'll increase that characters frequency in my map. Now if that characters frequency, if m of ch is equals to 1, that is that is we saw this for the first time, will reduce the VOWELs, will reduce the vowels. Now if it is not a vowel, that means it's a consonant. So consonant means I'll reduce the consonant. Consonants can be same, right? Exactly, k consonants, right? I need uh, so my consonant should never go lesser than 0, right? These things will happen, is not a problem, but I'll have to make sure that while my console is lesser than 0, if it goes lesser than 0, it means I should not be doing that. So I'll increase, I'll do the things opposite way. So if this is a vowel, a consonant, car, so instead of this, r plus plus. प्याज कम बोल देता था. Now if word of left is a e I, if word of left is a e I o u, that means left hand side is this. Then if left, the minus minus, and now if it becomes 0, I'll increase my vowel. Else if it is not, I'll increase my consonant. Correct. Now at the last I need to check if my conso is equals to 0 and an vowel is equals to 0, then my result will be increased. And also after this my left will increase. Okay, so it's vowel 0 1 and 2, 0 1 and 2, then it should be 3. No? Okay. So it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so till here its frequency became 1, and now we got another consonant which will do what, which will reduce my consonant. So consonant was, earlier consonant was 0, now it became -1, correct? Which we don't want. So in that case, let me do one thing. Okay. 0, 1, and 3, correct? Now what will happen? What's the constraint? It's 10 to into 10 to the power 5. Okay, we got a wrong answer. Okay, okay. Let's see. IQEAOUQI. Expected is 3 and mine is 2. What's K? K is nothing but. So I need 2 consonant. So this is a vowel. It became 1. Q is a consonant. Consonant, that means it's vowel. From 5 it became 4. Now I need 4 more vowels. One more consonant. E is also a vowel. 3 more vowel. A is also a vowel. 2 more vowel. O is also a vowel. So one more vowel, and U. So A, E, I, O, U. Now Q is also is a consonant. So so this becomes 0 and 0 from here till here. Now if I add this, this I becomes 2. But there is one more, which is this, by removing this. Okay, that means there is 3 possibilities, but I'm only counting 2. So in this case, what can be done? If my vowel is more than one, this will give me a n square solution, which is not optimal. Even if we apply sliding window approach, we are getting some hiccups over here. Uh, what can we do here? What? If we know, if we somehow know, if we somehow get to know that. So it's not only with I. It might be possible that there are multiple A's over here. Suppose A. There are three A's, and if we get another A over here, this whole is one of the possible. This is one of the possibility. This is one of the possibility, and this is also one of the possibilities. So, and if I remove I also, this is one of the possibilities. So. Keeping consonants as one will also not help me. I need to somehow figure out. So A E I O U. So from here till here I'll get two consonants and rest vowel. So my answer will move from 0 to 1. Right? If I include I also, then also there is no issue. But if I include this A, our answer will be 3. But one more possibility is this, which will give me 4. One other possibility is this, which will give me 5. Another possibility is this, which will give me 6. Another possibility. Now this will give me 7 as answer. See, going brute force approach for solving this one is not that difficult. It's not that difficult because we have a higher constraint. If I'm able to somehow, if I'm able to solve this always gets me. I don't know why, but I need to figure out how to work out in these kind of situations. This is not at all 3. How to work out with these kind of situation? Any idea, chat? Can I think of some other approach? Can we think of some other approach? Let's see if any other approach can work. Same consonants I need as 2. Vowel is always there. So A. For A from 0 it went to 3. I is 1 Q. Q is nothing but 1 E. 1 A went 4 O. U is 1 Q is 0. Now vowels, all the vowels are used, and K is also used till here. Now this is one of our answer. So our answer will be from 0 to 1. Now I reached to this conclusion. Now what I will do, I'll try to reduce my left. Let's try it. I reached to this conclusion. I'll try to reduce. So from 4 it went to 3. Still, my vowels did not change. So my answer will be updated to 2. Now again I removed one more A. Answer went to 3. It went to 2. Now we have 2. Now again if I remove this, my answer went to 4. Still we have 1. So we have 1 left. Correct. Until and unless we reach 1, we'll move. Now I'll add one more I. Now I became 2. I can remove this, can add this in our answer. Now so after removing we came till here. Now we add one more I. That was one of the answer. By removing we get one more. One more will get 7. Now this is a consonant. Now I cannot remove this consonant, right? If it is a vowel, then only I'll be doing. Okay. Now when when this is the case, still have 22 minutes left, so it's fine. Now they both are 0. I need to check whether it is a vowel or not. Word ka left if condition. If word of left is somehow A, E, I, O, U. So care, One second. So, in this case, what will exactly happen to my situation is it'll go till here. It will go till here, and then it'll see if it is fulfilled. Then it'll check this character is more than. Might be possible that I could have been multiple. So this will be nothing but a while loop. While consonant and vowels are zero. Uh, word fl. Uh, if that character is a vowel. I'm not asking for consonant. I'm asking for a vowel. Word of L. While m of letter is greater than 1. While word of L is equals to word of left is equals to this letter, and that letter's frequency is greater than 1. Remove this, we don't want this. Let's see. So m of word of L or letter minus L will increase. And my result now again another character will come. but this will what if this a, so this whole will be an answer. No, this will not give me the correct answer. By including this character, how many answers can I make? Means somehow something is varying. Wait, no, this is not the correct way to solve. I'm saying at this position we were able to make our consonants 0. Now I need to check vowels. Is vowels 0? Yes, it is. Now I need to know where was my first consonant placed. It was placed over here, right? Now from this consonant till this consonant, these from these whole consonant, how many in the last consonant which was which blocked us, like I like suppose there was one more q over here, so this is the last consonant. These we are considering these two consonants, so from our iteration would have been from here till here. So this is our iteration, right? This is our last consonant. I cannot move beyond this, correct? From here till here I need to know what is the possibility. What is the possibility? I. Now I need to know a position where uh, like before this I need to include this. So from here till here I have to include at any cost. So from here to here I need to know the position where till where if I remove uh, my vowels will not complete. So like a, if I remove these three a, I'll still be having a over here. I if I remove all the three I won't be able to complete my vowels. So till here I can. So how many characters did I remove? 1, 2, 3, 4, 5. So my answer will be added with 5 directly. Now suppose next I include this also. So this is also included. This is my and this is my breakpoint. Now again I need to know. So this time, because of this, all 6 can be removed. So plus 6, this, and this. So 1, 2, 3, 4, 5, 6, and 7. So plus 7, I think. One more. So instead of 5, it will be 6. This 1, 2, 3, 4, 5, and 6. Right. 6 plus 7. Now if I include A again, I still have to include this A. This is my starting consonant position. This is my breakpoint. So till from here to here, I need to know how many like this is what I need to figure out. If this I can figure out, I'll be able to solve it. Now how many are there from these breakpoints? So we have 3I, we have 3A, and total we have 4I and 5A. That means total I is 4, and from here backward I have I as 3 and A as 3. I also, in total I we have, that means we have I also, we have A also. It will be something like this, and if we get a consonant again, our breakpoint will be this consonant to this consonant, whatever values we have, we it is quite complex. Do we have any better approach in solving this? Let's see the discussion forum. Yeah, we have a sliding window. approach. The problem naturally leads itself to a sliding window approach because we are dealing with substring which are contiguous segments of original string. However, this problem requires some modification to the general sliding window technique. You need to keep track of two conditions simultaneously. Okay, the presence of all vowels and count of the presence of all vowels and the count of consonants. Correct. How many vowels are present and the count of consonant. Fine. That's we were handling this part. Fine. The valid window can extend beyond the point where we find a valid substring, as adding more characters to the right might create more valid substring. The right can extend before the point where the next consonant found. This will alter the condition of k consonant. The efficiency of this solution hinges on a crucial insight. We don't need to explicitly extend our window to the right to count all valid substrings starting at the left pointer. Instead, use a pre-calculation to achieve this in constant time. What is this pre-calculation? Let's walk through the code. The counter substring function, explaining each part in detail. We have another. We took another map for this vowels and consonant count. We also have a console, and this is nothing but our result. So this was the initial pre. We initialize our variable and length of the input string, vowel as a hash map to keep track of vowels and their counts, consonant to keep track of the number of consonant in our current window, result to. That's fine, that's fine. Now this pre-calculate is something that I need to understand because most of the time if I'm tackling these type of question, I have to have these things to be in my mind. Like if this comes, I need to pre-calculate something. I need to pre-calculate something. This is what it should come in my mind. If these kind of situation comes, I need to pre-calculate something. So this is array I stored. Last consonant is n. For int I is equals to n minus 1, I is greater than equals to 0, I minus minus. Next consonant I is equals to last consonant. There is a is vowel, if this is a vowel or not. We pre-compute the next consonant array. For each index, it stores the position of the next consonant. This is crucial for efficiently counting valid substring. Okay, so it's counting the next consonant from behind. Uh, last consonant which will go beyond the array size. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total 15. So it will be 15 consonant is 15. So at this position, this is a consonant. So my positioning will be I 12. If it is not a consonant, 12. Uh, 2, 3, 4, 5, 7, and sorry, for here it will be 0. So at this position, so it is updating the last consonant. It is not exactly updating the position. If it is not vowel, if it is a consonant, so it is not updating this. Here the next consonant is 15. So it will be something. So at 0th position, the next consonant is at 7th position. At 7th position, it will say next consonant is at 12th position, and 12th position, the next consonant is going beyond the array. This is what it pre-calculated. That is fine. So I need to have two consonants. So these two consonants we took 7 and 12. So these are the two places we took. I need to know we don't need to explicitly extend our window to the right to count all the values. When we find a valid substring containing we can immediately count all valid extension of the substring without actually extending the window. The calculation result is equals to result plus next consonant right minus right. Add the count of these. Okay. Instead of going from this side, it went from that side. Means he's saying that from here till here we have we have a solution. We have two consonants. Now this position will tell me what's the next consonant, right? So before that, I have these many mm, vowels. 1, 2, 3, 4. I can take them in our answer. I can consider all of them in our answer. Means this, this. But did we consider this in our answer? No. This array in answer? No. This array in our answer? No. No. We haven't considered these all in our answer. Yet. Okay. So what's the sliding window is saying? Left and right is 0. Right is lesser than n. Expand window. If is vowel. If this is a vowel, fine. So vowels, we have a map of vowels. So we increase the vowels, else it's a consonant, so we increase the consonant. Shrink window if too many consonants. If consonants is greater than k, consonants count is greater than k and left is lesser than equals to right, that's fine. If a vowel if that is vowel, reduce it. If it comes to 0, erase it. Else consonant, reduce it. This is fine. This is what I was doing. This is what I was doing. Now if we have more than k consonants, we shrink the window from left until we reach exactly k consonant. This is what we are doing here now. We start our sliding window. As we move right pointer, we Vowel dot size is 5. Fine. And consonant count is equals to k. Means this is perfectly are considered answer. If there are two consonants and five vowels, result will be nothing but this positions next consonant minus right. Nothing but 12 minus 7. 1 2 3 4 and 5. So we have 5. We added 5 in our result. We added 5 in our result. And then what we did is we moved till here. Then here. Then here. Added 1 2. A E I. A E I. So suppose this is where we reached. So this is then this. Okay. So in this case we should pre-calculate something and move forward instead of counting it from backward. We should be counting it from leftward. My goodness, this is the thing. It is actually a sliding window, but something we need to think over here. great. Just simply great. Awesome solution. Okay. Give me a 10 minutes of break, and after that I'll code this out in my way. But this is something I shouldn't. I should. I do not. I should not forget that if these kind of things comes, I need to pre-calculate it with the future, and not with the past. Maybe something, but we need some pre-calculation over here. Unless and until we won't be able to do that. So we need some pre-calculation. Okay, fine. I'll be back in 10 minutes, and then we will start coding. I'm back. Okay. 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 Before coding it, let's do one dry run. So till here, my two consonants is fulfilled and my five vowels are fulfilled. I'm considering this as a character and taking so this whole substring. So 1, 2, 3, 4, and then taking this. We reach here. My left will stop here, and now my right will go until and unless I reach here. From here, I'll go this. Oh my god, so so elegantly the approach has been created. So nice, so nice, so beautiful. It's something we need to take care of. If we are moving forward, uh, we need to handle it. So what we are doing is, till here we are 100% sure that we have vowels and consonants. Now until and unless I reach another consonant, I know that if we include these in our answers, it will obviously make our answer correct. It will not defy our answer. So I can consider all of them. Now if I remove one E from here, now still if this follows my consonant and vowel rule, I can consider all of them also. Because we cannot move backwards, we can move forward. Let's try it. So we have two things. We have left and we have right as 0. We have unordered map as character and integer. Vowel. And we have a long result as 0. Now something we need to recalculate. Let me take next. It will be next consonant of size n. So if I is equals to n minus 1 next consonant is equals to And let me create a vowel method also. Is vowel which will return boolean is vowel which will take a character, and if ch is equals to a, or ch is equals to e, or ch is equals to e e I o, if any of this condition is correct, then true, else return false. Next consonant I is equals to, if not is vowel, so this will this will do the pre-calculations. Now while right is lesser than n, till that now if is vowel word of right, vowels word of else consonant. I don't have a variable named consonant. We have vowels. So if it is a vowel, then vowel. If it is a consonant, then consonant. Now, while my consonant is greater than k, if consonant goes beyond k, then we need to do something. if if is vowel word of left, if word of left is a vowel, then we need to vowels of word of left minus minus. VOW. Vowels of word of left else consonant minus minus, and my left will be did I miss any bracket? This is extra bracket. Okay, so while consonant is greater than K, now if vowels dot size is equals to 5 and consonant is equals to K, now this will be a while loop. I reached here, from here till here I reached here. Now I am saying this position will contain the next consonant. So all the characters till next consonant is in my answer. So E result plus is equals to next consonant of Now I remove this character. I move shift left to the next character. So removing this character, if it is a vowel, as always my right. Okay. So the only thing that we had to have is whenever these type of things come, do remember to do some stuffs like this, and this will only come with practice. We know sliding window, but this is something a good approach of sliding window. I would copy this and I'll keep it somewhere so that I can remember. Maybe sticky notes new. What is this new sticky note? What is this epic pen toolbar? I can even pop this note out. Okay, this is also not bad. This sticky note and this sticky note is very similar, same. It's almost same. This is a new version, I would say. It's a good sliding window approach. I can copy this same code and paste it over here. And it will get accepted too. Pre-calculation. sliding window with pre-calculation. A good problem. This is a very good problem. Okay, nice. So somehow we were able to understand it, even though we were not able to make it on time. But still, we understood the solution, how the pre-calculation can be used. I always got stuck. Now I will remember this. Let's jump to the next question. Sorry. Hey, it's the find the kth character in string m1. This is string m1, and this is string m2. Oh, it's the same question, but there is some thing messy over here. The k is 10 to the power 14. Operation I is either 0 or 1. 0 or 1. Okay. There is another thing, that is operations over here. Okay, let's see. Okay. So it is saying when it is something like that, we need to do that. Else, if it is something like that, we need to do that. If operation is 100, operation length can be of 100. Now, after doing all the operations, after performing all the operation, return the value of the kth character in the word after performing all the operations. Even if we perform all the operations, if my k if my result dot size goes beyond k, I'll stop there. I won't be performing any further operations. That is one thing that I can say. Okay. So let's see. Oh, okay. Just a minute. I'll be back in a minute. Just back. So operation, depending on the operation, if nums of I is equals to 0, then we need to do something. So then what we need to do is result is equals to result str string temp is equals to result, result is equals to result plus temp, else else I'll have this. Okay. Now count result dot if result dot size is greater than or equals to k, break. I don't want anything else over here. Same. A and B, but I don't know if what will happen if k is 10 to the power 14. What? K is 10 to the power 14. Oh my god. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14. Child 1, 2, 3, 4, 5, 6, 7, 8. It exceeded the memory. I knew that this will be the case. I knew that this will be the case. Now in order to reduce the memory, what can we do? plus temporary. Like, can we somehow get to know? Like, instead of adding a new string, yes, yes, something I can do for reducing the memory. Like, for example, uh, I'll keep a count variable. Suppose it is 0, my word, or my result. Result is nothing but suppose a a b b b b b. Somehow it is this. Okay. Now, if my operation is 0, I just need to copy this. And if my k, I know that my k is 3 4 5 6 7 8 10. So why do we care about this? 10, the rest, like, again, new characters will be appended to this. I don't care about this previous characters, right? These characters need to be removed. I don't care about these. The only thing, I need to keep the count stored somewhere, right? That these many characters were there. And if the operation is 1, then also this will go, and we don't care about this. Somehow I need to remove the previous one and keep track of the next characters. But uh, but no, not exactly. If I somehow, like, suppose my character was a and operation is 1, so it will be b appended. Fine. The next operation is again 1. Then what will be appended? Appended will be b and c. It is depending on the previous characters. No, it is depending on the previous characters. From A I went to B. That is fine. But for this, I used this also, I used this also. And if there would have been more, I could have used those also. Okay. will still go memory. Is there any other way that we can think of to reduce the memory optimize the memory? Can we use something or the other to optimize the memory? How can we optimize? Three. This new three characters is dependent on the previous three characters. These new three characters is dependent on the previous three characters. Now these new six characters is dependent on the previous six characters. Now the next characters will be depending on these previous four characters. Four list. How can we optimize the memory? Is there any way we can think of optimizing the memory? It is being dependent on the previous characters. We need to remove the dependency, or we need to somehow know that the even if we are dependent on the previous characters, we have to get to know. We need to go to that character. Is there any wrong answer over here, or memory is the only memory element exceeded? Okay. Not really. How to optimize the memory? Any hint, or maybe optimizing the memory? Let's check. Mutations. Popcorn. The key observation is that the length of the word doubles with each operation. Correct. This allows us to reverse the process by determining which operation led to kth character without constructing the full string. Word length grows exponentially. Each operation doubles the string length, so we calculate the minimum number of operations needed to reach at least k characters. Reversing operation, we simulate the process in reverse, halving the length at each step. When we cross the midpoint of the kernel, indicate that the desired characters came from the second half of the word in the previous operation. Okay. As doubling everyone. So it did not generate the whole string, correct? What it did, it find the length. The extreme point. It found out the length of the extreme point, extreme right. It's a Python solution. Can I go back to? Okay, just a second. Uh, okay, I'll be back in 10 minutes. Let's take a 10 minutes of break. Okay, I'm back. Okay, so where were we? We need to find out how many times the character A mutated to get to the position K. We first determine the index OP of the final operation, log K base 2. The size of the word would be the word by half until we only one character remains A. If K is in the right half of the word. Operation is greater than equals to 0 minus minus operation. If this is this, then A plus mutations modulo 6. Is there something better? I don't know what was this. Each operation will double the length of the string. The length of the string will be 1, 2, 4, 8, 16. Correct. Update K minus is equals to 1. We want to find S of K. Consider K in binary format. It's kind of a weird question. We can see that character on each index of my present state is dependent on the previous string characters. Every time the length of the string is doubled whenever we perform any type of operation. Correct. If I am currently at kth index, then it is certainly be built using the previous string just before this transaction. Correct. So my current string is dependent on the previous string, so we can think of recursion. Kth character of the current string is certainly be the k minus power of 2I, where I is the operation using which my current string is built, that is floor. If the current operation is 0, then it will be the same character in the previous string, else it is one character above it. See code for better understanding. The previous string, else it is one character above it. Okay, K is my operation and this is my operations. If K is 1, return A. But What is this I minus minus? Okay. If it is the kth, suppose if k is 10, I know it will be, it is based on operations. One, two, three, four, five, six, 7, 8, 9, 10. This is 10. How can we generate this? We do 0 AA. If we do 0 again, it will be AAAA. If we do 1, so it will be BB, 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 BB. BB, BB till here. If we do operation 1 again, it will be B, 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 C, 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 C. Now K is 10. Now this operation is 1, 2, 3, 4 and 5th. So this is something called zeroth operation. I don't care about this. Majorly it will start from here. 1th operation, 2nd operation, 3rd operation, 4th operation. So it is actually nothing but 0, 1, 2, 3. So in 3rd operation we are getting this. Now 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's take 12 for a better understanding. So 12. We know that 12 lies in the 3rd operation. So 3rd operation was 1. That means it must have came from 2nd operation. With 1 character less. Means if it is something x, so in 3rd operation will be x minus 1. Now in 3rd operation also it is 1. In 2nd operation it is 2, so it will be x minus 2. In 0th operation it is 0, so it will be x minus 2 over here. It is a plus 2. subtracted 1 from k because it was a zeroth index. It was going from zeroth index. I 0 till n, and then I is lesser than 60. Why is 60 we added if we do not include this? For now I is 0, I is lesser than n is nothing but operation size I plus plus. Why k shifted I times? Update, consider k in binary format. S of 1 x x x is generated from S of x x. What is this S? If the operation is 0, if ith bit in k is 1, it will apply operation. Count the sum of applied operation. Just a second. Why if the ith bit in k is 1? If ith bit in k is 1, it will apply operation I. Why? I didn't get it. it it found the iteration. Fine. Log will tell me the number of count so it will be something maybe 4 or 3, something like that. So k will always one left shifted I times. So it will be something 1 2 3 4 8 8 times then 4 k minus 8 k minus 4 k minus 2 k minus 1, something like that. It will go subtracting. Now if k is greater than uh, if operation is 1 of I is 1, right? This is what I was thinking of it. I was reducing it. I was reducing the count value. Even I can increase the count value. Yeah, this is what the approach that I went for, right? I was reducing the count value. Instead of that, I will increase. The only thing that I need to know is this will give me what? Math dot no, there's no math here. So int I will be nothing but log of, we have direct log, right? Log of k. Log if I change to Java and system.out.println log 5 log base excuse me evaluate log base 2 of 5 ठीक है भाई what is it's 2 point something it's 3 point something so what my code was giving log base 2 C plus plus log 2 if k is 10 so a then a maybe operation if operation is a 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 3 so k is 10 so log of 10 base 2 is nothing but 3 now 2 to the power 3 is nothing but 8 1 2 3 4 5 6 7 8 then 4 then 1 which is 2 and 1 which is a so I'll be subtracting this power that means 1 left is shifted I times 3 then I will reduce 1 2 then 1 more it will reduce and if ith operation is 1 then my count will increase it's k subtracted 8 what will be left in K? Why this condition is checked? Calculate the highest power of 2 that is less than or equal to K using logarithms. Fine. Use a loop to decrement K while checking the relevant operation of each significant bit. If the current power of 2 is lesser than K, if operation is 1, increment the count, decrease K by the current power of 2. Else I will reduce. Will print me 3. So K minus 10 minus 8, that is 2. Okay. That is 2. And then 2 to the power 2, that is 4. Which dropped me to this position, right? Okay. If K is greater than 1, L left shifted I times. Operations of I. If operations of I is equals to 1 will increase I, else will not. I will be returning A plus count Okay, so this was a nice question. I'm still having some doubt in this. Yo, Aradhya Verma, yo, welcome to the stream. Well, I'll go back to this question again in future. Okay, now let's go to some another contest, and because I have left already lots of contest previously, let's try to solve. Okay, so today's contest was something 4, 5, 7, and 8. So easy question, still having doubt. It's really easy. I think you can solve it very easily now. Of course, already solved it. Great, 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 great. Okay, let's try to solve these two questions first, and then we can go for third and fourth if possible. Okay, so the question says maximum possible number of binary concatenations. So we are given an array of integers nums of size 3. Okay, it's of size 3. Return the maximum possible number whose binary representation can be formed by concatenating the binary representation of all elements in nums in some order. Note that the binary representation of any number does not contain leading zeros. How many questions did you solve, Aradhya Verma, today? You know what string is? How to solve string questions? No? I don't know. Return the maximum possible number whose binary representation can be found by concatenating the binary representation of all elements in nums in some order. Just a minute. Return the maximum possible number whose binary representation can be formed by concatenating the binary representation of all elements in nums in some order. Does not contain leading zeros. 1 2 3. Output is 30. Concatenate the numbers in the order 3 1 2 to get the result. Return the maximum possible number whose binary representation can be found by concatenating the binary representation of all the elements in nums in some order. Okay, concatenating the numbers 3 1 2 to get result is 3 is something this, 1 is this, 2 is this, which is a binary representation of 30, which is maximum. So for 2 8 16 the order is 2 8 16 only, this, then this, and nums of I can go up to 127 only. So we can rearrange and check. There will be 9 possibilities, right? 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1 1 2 3 4 5 6 6 possibilities. 6 possibilities, and out of these 6 possibilities, whosoever is the maximum will be our answer. Now concatenating is something which we need to do. So from here I have to go till here. So 3 is nothing but I'll start from 2 to the power 0, 2 to the power 1, and then 0 2 to the power 2, then 1 2 to the power 3, and then 1 2 to the power 4. Okay. What can we do for the permutation? Maybe I can do recursion for this. And whichever is maximum, I'll be returning that. Okay. Maybe I'll do solve. And I'll pass nums. That permutation is something swapping, right? Just permutations, lead code. We can use the swap method. Uh, uh, uh. Is there any other way that I did swap? Yep, backtracking, swapping. This is what I wanted. Permute. I am having an answer list. I don't want that answer list. I simply want this backtracking. Okay, so this is my backtracking. Comma, find val now this find value will take this and pow is equals to I is equals to nums dot size minus 1 I is equals to nums minus I. Answer plus is equals to pow. Pow into is equals to 2 or pow is equals to pow left shifted 1. Num is equals to num right shifted ones. Okay. Next is remove methods from project. Let's solve this question and then I'll take a break, a lunch break. Remove methods from project. You are maintaining a project that has n methods numbered from 0 to n minus 1. You are given two integers n and k and a 2D integer array invocations. And a 2D integer array in invocations, where invocations I is equals to a of I comma b of I indicates that method ai invokes method bi. There is a known bug in method k. There is a known bug. Method k along with any method invoked by it, either directly or indirectly, are considered suspicious and we aim to remove them. A group of methods can only be removed if no method outside the group invokes any method within it. Return an array containing all the remaining methods after removing all suspicious methods. You may return the answer in any order. If it is not possible to remove all the suspicious method, none should be removed. Be removed if no method outside the group invokes any method within it. Return an array containing all the remaining methods after removing all suspicious methods. You may return the answer in any order. If it is not possible to remove all the suspicious method, none should be removed. But they are directly invoked by method 3 and 0, which is not suspicious. We return all elements without removing anything. And there is a known bug in method k. Method k along with any method invoked by it, either directly or are considered suspicious and then we aim to remove them. If no method outside the group invokes any method within it. Okay, let's understand the question properly. 0 is connected with 1, 1 is connected with 2, 3 is connected with 2. It's a directed graph. Fine. Method 2 and method 1 are suspicious. A group of methods can, if no method outside the group invokes any method within. Method 2 and method 1 are suspicious, but they are directly invoked by 3 and 0, which is not suspicious. We return all elements without removing anything. Let's see where we are removing. So a suspicious element is 0, which is invoking 1 and 2. So 0 is invoking 1 and 2. Method 0, 1 and 2 are suspicious and they are not directly invoked by any other method. So 0 1 2 ही रिमूव हो गया, तो 3 4 बचा. इसमें 2 is suspicious. 2 is invoking 0 and 0 is invoking 1, 1 is invoking 2. All are suspicious. Okay, so if I see this 0 1 so 0 is suspicious. 0 is invoking 0 as 1 and 2. They are being directly invoked by 0. So 2 and 1 are also in suspicion. Now 2 cannot be invoked by someone outside this group. 2 is invoked by 1, but it's fine because 1 is also in suspicion. Okay. There is something hidden over here. Small thing that I just want to know. Like from 0, I'll get to know all the suspicious nodes because to whoever 0 is connected, all are suspicious, right? So total 3 nodes are suspicious over here, that is 0 1 and 2. Now I need to know 0 is connected like except 0 because 0 is obviously suspicious. 1, if 1 is directly connected to another any other node which is not suspicious, then we cannot remove 1. And it is saying that a group of method can only be removed if no method outside the group invokes any methods within it. In this case I need to know any So only one is suspicious through which we are finding everything, right? So we need to know any method which is directly invoking. One. We need a reverse graph from one where all I can go. And if I find anyone who is suspicious, I need to remove the node left 0 1 2 3 4. So 0 1 2 is suspicion, so 3 4 is left.
How old are you?
Nodes suspicious. So let's find all the nodes who all are suspicious, right? To reach a node which is suspicious, and then we can stop, right? This will work. This will work. So what we will do is we'll find all the nodes which are suspicious, and we'll keep it somewhere, maybe in map, unordered map will be set. Suspicious sus node, suspicious nodes. Okay, so these are suspicious node invocations. I need to create a graph. Okay. Okay. Now from num nums of I of, I'm doing so much mistakes. Int 2 is equals to nums of from 2 to right, and I'll put it in graph from dot. I don't need any reverse graph for this. Visited of size and no suspicious. Find suspicious. We'll be starting from K. I'll be giving him graph. I'll be giving him visited. Uh, and also will be giving him suspicious nodes. Okay, so we are getting node. We are getting the graph. Graph. We are getting the visited array. Comma ampersand, and we are getting suspicious nodes. Fine. If g dot find is equals to g dot n, because it is a directed graph, I can return directly. If not, I can go let's call this find will only be called if visited. I have already visited this node, so it will be 1. So I'm not going to visit it again. Right. Visited of new node. Let's make a new node. New node is equals to g of node of I. A visited new node is equals to 0. That means I'm going to visit that node. That Just a second. Suspicious node, right? Sus nodes dot. Even I don't want this. I don't need this. Visited. I can directly call find suspicious nodes with this new node. Rest everything will be same. G visited suspicious nodes. So this will give me all the suspicious node list. And now visited of I means I haven't visited that node. Is not sus. We'll go with I. Now I know the suspicious node, total suspicious nodes. Auto IT is equals to sus nodes. So then I need to check. फर्स्ट में 2 1 मेरा सस्पिशियस नोड है, मेथड 2 एंड मेथड 1 आर सस्पिशियस, करेक्ट। सेकंड में 1 0 1 2 है मेरा सस्पिशियस, सेकंड में 0 1 2 है मेरा सस्पिशियस, और थर्ड में भी 0 1 2 है मेरा सस्पिशियस। तो सस्पिशियस तो मेरा सही आ रहा, तो सही है। अब मेरे को क्या करना कि जो विजिटेड नहीं है वहाँ से अगर हम इस सस्पिशियस में पहुँच रहे हैं, so then make something, right? Int bull इस नोड से ग्राफ को विजिटेड को और सस नोड्स if reach is equals to false, then result dot push back ग्राफ है, विजिटेड है, सस्पिशियस नोड्स है, सेंड आंसर है, let's keep it bool, I have visited this node, now if sus nodes dot find this node is not equals to sus dot end suspicious, that means this node is there, return false. I is less than g of answer dot pushback. If this method returns false, then return false. Return to no. If we are getting true from here, okay, this pushback will give me an error. That okay, fine. There will be a mistake. There will be a mistake over here. I need to figure out the mistake. If I'm directly returning, if somehow my case is something like this, maybe my 4 is connected with this, and 3 is connected with something like this. These all are suspicious nodes. This is not. So from 4, if I reach 0, I'll return false. From 3, if I reach 4, I see 4 is visited, but whatever value this contains should be returned. That means whatever value visited. So I need to know Okay. Okay, fine. I'll do that way. Let's do that way. Excuse me. I have a vector result. Let's keep a vector visit of size n. It should be boolean. Bool. So if visit of I is equals to true and sus nodes dot find I is equals to then call this is not suspicious with node as current node graph visited will be something bool. So after visit I need a list of sus nodes and answer. Now instead of direct returning okay. What else? I need to figure out a proper way. This is not going in a proper way. If this is a suspicious nodes list, so maybe 5, 6, something like this. Okay, so I start with 4. If 4, from 4 I can reach this this suspicious node. This 4 will store false. And if I don't reach, this will still be true. But I have already visited this node, right? So I need visited also and true false also. Okay, I need two things. I need visited also and true false also. Or 3 values. Visited, true and false. 0, 1 and 2. not visit, sorry, not visited, and if visited, are we getting true or we getting false, or are we getting false, something like that. So we visited this node. So let's take three values. For suspicious, mark it as 5. Visited of I is equals to 0. Now I need to handle here. Okay, how are we handling? Sus node dot find node sus node dot end. Okay, okay. So if we are in a transition of visiting, from 4 we go till here, till here. We did not find, so this will be true, this will be true, this will be true. Means what? From here, if we are touching this suspicious, I cannot remove this whole suspicious list. So from anywhere, if we are touching this set of suspicious, this group of suspicion, we cannot remove it. And suspicions is a list from anywhere. From anywhere, if we are reaching this, then we cannot remove, we need to add. Why I'm getting so much confused over here? It's not that confusing. I don't need this answer list. I don't need to push it anywhere. I just need to find from anywhere if I'm touching this. If I haven't visited that node, let me visit it. And suspicious nodes, if I found it, return true. Or if blue bull, if I'm able to reach, don't remove will true. Will yes, if suspicious node dot find, is not. I'm confused it a lot. Visited of I0 is not sus. I G visited and sus. No, don't remove. If we are getting this as true, what we are doing is making that as visited. Means I found it. That this node is in our suspicious node. I'll return to. It's y03. We are only getting 03. Y1, not 1 2. Suspicious nodes. For this we did get that. Started with 0. Correct, 0 was not the suspicious one. So 0 is not in our suspicious end. For first it is 2 and 1. So for 2 and 1, 0 I'll not get. I'll move from 0, I can go to 1. 1 is visited. Let's make it 2. Zero one 0 1 2 3 0 1 2 3 3 4 and empty. I think there is one mistake. I'm not sure. Wrong answer. Oh, it's not. Fine. I mean, it means I should have removed. I have to remove. I'd have to removed. A group of method can only be removed if no method outside the group invokes any method within it. This line was the major thing. Okay, so finally I was able to accept it. It got accepted before time. Thank God. Thankfully, still got 20 minutes. But yeah, this was a good question. Not sure if I'll be able to solve this question or not, but I'll give it a try offline. Okay, so maybe today I'll stop here. From next week onwards, I'll try to increase the timing. For today, I think I'll stop here. I'm feeling very hungry right now, so I'll go grab some lunch. And whosoever is watching, please like and do comment. Let me know who is watching the stream. Okay. So next week I'm thinking of solving some CP questions also. This week I'll try to solve more of the contest questions because I was not able to solve the contest questions earlier. So I think two more are left. I'll try to pick questions from these two contest and solve in this week. After that, I'll come back next week on the live stream. Okay. So it was really great. I got to know about this sliding window approach. I'll try to remember this as best as I can. So this is something pre-calculations, doing some pre-calculation which needs to be there, because without that it'll be very difficult to find solution of these twisted type of solution. So nice. Okay, thank you guys for joining in. I hope you liked the stream. Please like, share, and subscribe my channel. And I'll see you next week, Saturday, 9:30. Back with another live stream. So okay, till then, enjoy, solve more questions. See you. Bye bye.